All right, so this is assignment 4.6. I'm going to do these 4 problems. I'm going to do this proof right here. Once it pops up, lagging. That's okay. Proof number 17. Then I'm also going to do proof number 25. So I think the directions for the first problem, I cut them off, but I think they are tell us why the triangles are congruent to each other. So the first one, let's see here. Why are these triangles congruent to each other? Well, it's a right triangle, so I'm already thinking HL probably. And then let's see here. 6 is congruent to 6. Oops, sorry about that. 10 is congruent to 10. Mark your diagram. So now I have a leg here, and I have a leg here, and I have a hypotenuse and hypotenuse. So these are congruent by HL. Now, when you let's add 2. So let's call these triangles congruent now. So I'm going to go, I always like marking my sides. 1, 1, 2, 2, 3, 3. And there's a lot of different ways you can do this. So I'm going to start at A, triangle ACB. So if you look, I went 1, 2, 3. 1 tick mark, 2 tick marks, 3 tick marks. And it doesn't matter how you do it, you just have to keep it the same. So if you think about it, now I need to start at D, because that will, if I start at D, is congruent to, I will go 1, 2, 3. If I started at D and went to E first, it would be 3, 2, 1. If I started at F and went to E, it would be 2, 3, 1. So I have to keep the order the same, and that's why I like marking the tick marks first. Let's undo all that stuff. Okay, good. So triangle ABC, 1, 2, 3 is congruent to triangle D, 1, 2, 3, DFE. Remember, the order matters. The order tells us what angles are congruent, and it tells us what sides are congruent to each other. Okay. This one, let's see if it's going to be congruent by hypotenuse leg or not. So we got vertical angle, so I can get this angle is going to be right. And then I have, this is congruent to that, so that's a leg. This is congruent to that, that's another leg. So we have hypotenuse leg again. So those two triangles are congruent by hypotenuse leg. Now again, mark your diagram and start wherever you want. So I'm going to start at P this time. So I'm going to go P, L, M is congruent to, so I started at P, I went to L, and then I went to M. So I went 2, 1, 3. So I have to go 2, 1, 3. So if I start here, I go 2, 3, 1. So that's going to be backwards. Undo. Clean this up a little bit. So I want to go 2, 1, 3. So I'm going to have to start at N. 2, 1, 3. M-O-N. Or sorry, N-O-M. Okay. A lot of people are going to say these two are congruent to each other. These two are not congruent to each other because we don't know anything about those angles. We can't do anything to find these sides, so those two triangles are not going to be congruent to each other. These two triangles, so I have my hypotenuse here with the reflexive property, and I have a leg, and these both are right angles, so these two triangles are congruent by HL. And let's put our tick marks in. So I'm going to start at R this time, triangle RXV. So go ahead and pause the video and see if you can figure out what triangle is congruent to triangle RXV. RXV. So I want 1, 2, 5. So I'm going to have to go 1, 2, 5. So RTV. That one's a little bit easier because the orientation of the triangle is a little bit easier. Okay, so mark your diagram and then use your tick marks to your advantage, right? Let's keep going. RS is congruent. So yeah, they're doing you a favor for sure because they're marking the diagram for you, right? But don't rely on that. You should be marking your diagram as well. So RS is congruent to TU. That's a given. RS is perpendicular to ST, and TU is perpendicular to UV. Let's put segments on top, also a given. So that's why we put these little angles here. Okay, T is the midpoint of RV, and then we're going to prove this triangle congruent to that triangle. So T is the midpoint. So I'm going to use this one first. That's good. I already got a side. What does perpendicular mean? So perpendicular means that I can get a right angle. So I'm going to get angle because RT, or RS is perpendicular to ST. RS is perpendicular to ST. So angle RST is right. And we can also get in that same step that TUV is right. That's a given. Now you don't have to do this, but you can if you want to, just to kind of keep it the same, right? So this is an unnecessary step right here. Not necessary, but you can do it if you want to. It's not wrong, and it just kind of keeps everything consistent. So I'm going to say angle RST is congruent to angle TVU, because if right, then congruent. And the reason why we don't, well, you'll see that in a second. Okay, so I use this, this, and this. T is the midpoint, so I can get RT congruent to TV. Yeah, sorry about my handwriting. Because if midpoint, then congruent. So now look, I have a right angle here, so I have right triangles. So I should automatically be thinking, okay, probably a hypotenuse leg. Then you have to make sure that your angle is excluded for hypotenuse leg, right? So is my angle excluded? Yes, it is, and the other two sides are congruent. So this is going to be triangle RST is congruent to triangle TUV because of hypotenuse leg. Cool. Again, this step 5, is unnecessary. Last step, this is a great proof. Put a little star by this one because this one's probably, this is very much at the level that we want you to be at here. So D bisects AC. I'll try to write a little slower, given. So D bisects AC. Notice I'm bisecting a segment, so I need two congruent segments. So I'm going to say AD now is congruent to DC. Right, slower. Because if bisect, then congruent. Okay, so I use that. Perfect. Let's go DB. Undo, undo. BD is perpendicular to AC because of given. So then you have to think about what perpendicular means. Well, I can get both angles, angle ADB, this angle right here, and angle BDC are right, because if perp, then right. Mark it. So again, I would always do this step. I would get them congruent next, because sometimes you're going to need the congruency with angle, angle, side, or side, angle, side, but sometimes you're not. So you might as well just do it, right? Just to make sure that you do it. So angle ADB is congruent to angle BDC, because if right, then congruent. I'll warn you right now, they're trying to trick you. Right? This is congruent to itself because of the reflexive property. And now I can actually get the triangles congruent to each other. Now, why are they congruent to each other, right? So you're in the hypotenuse leg mode right now. You're grooving on hypotenuse leg. Ask yourself, is the angle included or is it excluded? Pause the video and see if you can answer that question. Is the angle included or is it excluded? The angle is touching both sides, so the angle is included. So that means if I have blah, 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 the angle is going to go in the middle and the sides are going to go on the other two sides. That's why it's always nice to have this step right here, step number 5 again. Because if it were a hypotenuse leg, we wouldn't have had to have it. But since it's side angle side, we're going to need that congruency statement to prove those angles congruent side angle side. Okay. Good stuff. Try this. Check your answers.